Hi, Iffanice. Welcome to the podcast.
Hi, Robin. Thanks for having me.
It's an
It's great
absolute
to be
pleasure.
here. Yeah.
Excellent. So let's begin with a little bit about yourself.
All right. So I'm Iffanice. I work as an AI research engineer at InstaDeep, which is a company focusing on advanced decision making using AI for enterprises.
Hmm.
So specifically, I work in the AI for social good team,
Hmm.
where I have been contributing to the InstaGeo project.
Brilliant. And what specifically have you been doing? Are you a developer? Are you a user?
Yeah, so I've been contributing as a developer, of course, working on the different components
Mm,
of our package. So that would be the data component, the model component, and also working on the application component.
brilliant. Okay, well, I'm excited. You're going to give us a demo of the platform today. Why don't you take it away?
All right, so this is a platform available at instageo.io. It's currently hosted using InstaDeep infrastructure. So if you go on the GitHub repository, you can have access to the code where you can also see all the files necessary for the deployment. So if you want to deploy it on your own infrastructure, you can still do it.
Hmm.
All right, so this is the app component basically. So when you navigate to instageo.io, you will see this map application. Here you can see what we call the control panel. This is basically where you can select your models and run your inference.
Hmm.
But before doing that, you will need to sign in. So let me log in here. All right. So now when I open the control panel, I can see the different options to configure for
Hmm.
me to select the models and also my area of interest. So that's actually the first step. I need to draw a bounding box to select my area of interest. So I actually need to provide a little bit of background here. When we take the app component, basically what we want to do is to run inference given a specific area and a specific model. And to do that in the background, we will need to fetch the data. And that fetching process will actually be using our data component.
Hmm.
And the next step will be selecting the model and running the inference, which will also be using our model component.
Hmm.
So I'll start by first selecting my area of interest. I can draw a bounding box here, and you can see basically an information related to the bounds, the
Hmm.
area of interest. After that, I get to select the model that I want to use. So currently here you can see that we have three different models.
Hmm.
One for aerosol optical depth estimation. It has to do with air quality. We have one for biomass estimation and another one for crop classification.
Hmm.
So I can start with the biomass estimation. You can select a model size here. Currently, we have two different variants. I
Hmm.
will start with the tiny one. And after selecting those parameters, you get the information related to the model. So it tells you what you will get by using that model. So this estimates the biomass values from the satellite imagery for environmental monitoring.
Hmm.
You also get the information about the number of parameters, the chip size that was used internally to train the model, the number of steps, that corresponds to like the different temporal steps that we took while training the data. So you
Hmm.
can see for this model specifically, we use three different time steps. So just to show you, if I go back to the aerosol optical depth estimation one,
Hmm.
um, you can see that these models use uses only one time step.
Okay.
So let me go back to the biomass one, and you get to select the date.
Question, what does temporal
Oh,
step mean there?
right. So this is basically the spacing that we use between different temporal steps, basically.
Mm,
So for these models, we are using three number of steps. So it means from these dates, I will try to fetch the first chip corresponding to these dates.
mm,
Then, based on the temporal step, based on the spacing that I want to use, I retrieve the second step and then
mm.
the third step. So it's basically the number of days between the different steps that I use as for the data.
Right. And is that going back in time or
Yes,
around the
exactly.
window or okay, so back in time. So I say I want
Yeah,
three steps. The oldest step will be 3 times 50, so 150 days old
yeah,
with some sort of tolerance that you're adjusting here.
yeah, exactly. So here you see the data source that was used to train the model.
Mm,
So this model is using HLS.
mm,
So currently in our repository, we have enabled the retrieval of three different data sources. We have HLS, Sentinel-2, and Sentinel-1.
hmm
So if you actually go to the repository, you can get some interesting demo notebook
mm,
for the data component. Maybe I can even share that one later.
hmm
But here you can configure the temporal tolerance as well. So this is basically saying if I don't find data for this particular date, I can either add or remove a specific number of days from that specific date.
hmm
So for the date, you can also go back in time. So it will just try to fetch the data from the archive that we are using for that particular date that you have chosen.
Okay.
All right, and this one defines the maximum cloud cover. Um, so this is applied to the original satellite tiles that we retrieve.
Mm,
So just to mention that based on the observation data that we had during training, we had to cut the data into chips. So it's not like we were using the entire tiles from the satellite imagery.
mm,
But in order for us to select the particular chip or extract the particular chip, we need to identify the tile that will be used.
mm,
So this parameter will actually control the maximum cloud coverage that we'll use to filter the data available.
mm. Presumably you wouldn't
Yeah,
want 100% cloud cover.
yeah, exactly. But I guess for the sake of the demo, we can just use that default parameters. And
Mm,
what is interesting for the data pipeline is that even though you specify this is the maximum cloud cover I want to use, if it finds something that is lower than that, it will use it. So
right.
basically, using the temporal tolerance and the maximum cloud cover, I want to retrieve the data available within that window using the
Mm,
minimum cloud cover that is available.
yeah.
All right, so we can go to the next step. The next step is just to run the model. So you can see that here you get a pop-up describing the process that is being run currently.
Mm,
You can see that the data processing is running. And after that, it will go to the model prediction. So actually, based on the area of interest that you select, it might take some time to fetch the data before using that data for the prediction.
mm.
Yeah.
One kind of
So
technical question. Obviously, a user might select a very large area. How would you, does the system feed back to them that, you've selected a very large area and this is going to take a long time, or Is it just a case of experimentation to get a feel for it?
Right. So currently we have some limitations when it comes to the areas that you can select. I
Okay.
can show you, for instance, here. So if I decide to draw a large bounding box, you'll see
Okay.
this warning.
Right.
Yes, so the maximum allowed is this number. And there is
Okay.
also a minimum. Let me show you.
Right.
Area too small, minimum required is this.
Yeah. So if you want to do a really large area, you basically have to do several predictions and then bring them together yourself somehow.
Yeah, exactly. This is also tied to the resources on our side, right?
Mm.
Especially because this is open to the public. Yeah, we wanted to kind of limit a bit the area that a user can select in one go.
Yeah.
All right. So I can go to the task monitor. The task monitor shows us basically all the tasks that we run in the
Mm.
past and
Hmm.
also the ones that are currently being run.
Hmm.
So here you can see that I have other tasks that were completed, and the one that is currently running is here. It's still at the data processing stage.
Hmm.
So you get to see the details. But before the completion of this one, I can already show how a complete task looks like.
Hmm.
So here, yes, for biomass estimation as well, you can see the different stages through which we'll go. So
Hmm.
the first one is data processing, second one is model prediction, and the third one is visualization preparation.
Mm.
So here, basically, we are using our data components to retrieve the appropriate satellite images for the area of interest that is selected.
Hmm.
At the end of the process, you get some statistics. So you can see the number of chips that were created. You get to see the chip size, also tied to a model that was selected,
Mm.
and the extraction duration. Um, Yes, we can see that the first stage has completed for our
Mm.
task.
Hmm.
Yeah, you see the extraction duration here as well.
Right.
So basically what is happening is that once the user selects the area of interest, we pass it through the data component because there is a service that is running in the background, which will retrieve all the chips and then pass it to the model for prediction.
Hmm.
We see also that the prediction has completed, and we get to see also very interesting statistics about the CO2 emissions
Mm.
and also the energy consumed.
Hmm.
So to get this data, we are actually using um, Code Carbon. It's an open source tool for tracking compute-based carbon emissions.
Right. Okay.
Yes. So the models here, the models that you are using are trained using our model components. Just to mention that the current models that are available are using PritV as a backbone.
Hmm.
And in the future, we are planning to do more exploration when it comes to the modeling part.
Yeah.
Uh, yeah.
Question about that. So if I've trained my own model, I can basically add it to the system and just use it without needing to build all the infrastructure because that's already there, right?
Right. So this is not currently possible.
Okay.
Uh, but the only thing that would be actually interesting to do here is that um, okay, if you don't have the infrastructure to deploy the app, can be tricky, right? But we are not enabling this where you can come with your own model. I don't know how this is going to evolve in the future. It
Mm.
might be possible, but currently it's not.
Okay.
Um, but if you are to deploy on your own infrastructure, you just need to train a model, and you can specify this model as one of the model that you want to use in the registry. So you can see all those configurations
Mm.
available in the README.
Right. So just to clarify, so the hosted platform is not going to support other models, but if you run everything yourself, then it's straightforward to add other models as long as they're trained within the system itself.
Yes, yes.
Okay.
Yeah, I was saying for now because I don't know how it's going to evolve.
Hmm.
I mean, this platform that is currently open to the public.
Yeah. I guess for me, an interesting aspect of this is about how models will generalize because, people can come in and take a model trained over, Kigali, say, and then they might apply it in South America and the performance won't be
Yes,
very good. So I guess the natural next question is how do I handle that situation? And is that something that you guys have on the roadmap to sort of support?
yeah, so this will be, of course, tied to the data that was used to train the original model.
Mm,
And I can also say that it can be tricky based on the different areas
mm,
that were actually considered within the training data. I
yeah.
can also give the example of the crop classification task. So
Hmm.
this one was using the USCDL data for the crops.
Hmm.
So if you are to run inference, for instance, on Kigali, let's say, you might see some classes that are not supposed to be there, right? So
Yeah.
it's best if you run the inference of the US, for instance.
Mm.
Yeah.
Right. So for the time being, it's basically on the end user to, understand the limitations of these models and when they apply them. Um, but as you say, there's potential, I think, within the platform to surface that information as well and help people to understand, why a model might or might not be doing well in a particular case.
Yes, yes. I think on the README, we'll add some more information. Actually, we already have some of those information on the README because for the models that we are releasing,
Hmm.
we also have a preprint currently. So we have opened some models, and for each of those models, we specified the data set that was used.
Hmm.
So you can kind of get maybe an idea on the distribution of the data that is used for
Hmm.
training.
Hmm. Got it. But it looks
Yeah.
like our job is completed, so I guess we can have a look at the
Yes.
predictions now.
Yes. So the last step was the visualization preparation. This
Hmm.
was just taking the different prediction files, merging them, and converting them into cloud optimized GeoTIFF for visualization. So when you click here, you get to see a preview of the satellite data that was used and also the model prediction,
Hmm.
which you can add to the map. All right. So this is basically the model prediction. You can play around here with the different opacities
Hmm.
of the satellite data and the model prediction. If you maybe want to overlay it and see how it might relate.
Mm.
Sorry, I need to move this. All right. So you can see the satellite image
Yeah.
here.
Mm. Very nice.
Yes. And yeah, that's basically it for the entire process.
Hmm.
You select your area of interest, you select your model, you run the inference, and you get your result that you can visualize on the map.
Mm.
You also get to generate a PDF report that is a
Hmm.
kind of overview for the results.
Yeah.
All right, so here you get both previews And this also shows you the kind of distribution that you have for the predictions.
Mm,
So you can see that maybe the dominant window or range here is around 76.
mm,
And you get to see like the range of the values here.
mm,
And this is basically for the regression task. So this was biomass estimation. That is a regression task. I can show you an example of crop classification. That is a segmentation task.
mhm.
I, so going to the task monitor here, I can filter. Yes. So you can filter using the model that you want. You
Yep.
get a list of all the models here for biomass
Mhm.
and here for crop classification, for instance. So here, if I need to visualize, this is a segmentation task. I can do the same, add to the map,
Mm.
and also export.
And can you export that as a GeoTIFF as well?
No, so this is not currently enabled.
Right.
So what is happening here is that for the previews, we are using GeoTIFF like internally, but we didn't like open it for download.
Mm,
So behind the scene, we are using T-Tiler to serve those cloud optimized GeoTIFF.
mm,
Yeah, so for the segmentation task, you will get this kind of overview with the different percentages of the classes that are present within the prediction
mhm.
that you can see here, classes, 9% out of 13.
Right.
Yeah.
So you've got classification, you've got regression. Those are the primary tasks that are supported.
Yes, this is just a category for the task, right?
Mm,
So we are to add two different tasks. Currently, we have um, aerosol optical depth estimation, biomass estimation, and crop classification.
mm.
We want to add different models for flood mapping and also locust breeding ground prediction.
Okay.
I think Ibrahim might have mentioned that task, the one related to the locust.
Yeah.
Right.
Brilliant.
So yeah, that's basically it here. You can decide to remove those layers from the map.
One final question. If somebody wants to host this themselves, what are the minimum requirements to do it?
Right. I think that would be it's not requiring a lot of resources, also based on the workload, I would say. Because all of these at some point I had it on my laptop and
Mm,
it was just like using yeah, my laptop is using like eight giga. Sorry. It's an M1. It has 8 GB of RAM, so you don't need to use like a lot of
okay.
resources.
Yeah.
But if you are to scale it, you probably need more resources.
Yeah. Got it. Okay. So you can do the local development on a MacBook and not have any issues there, and then deploy it to the cloud when you want to open it up for lots more users.
Yes, exactly. Maybe you might face issues when it comes to the large models,
Mm,
but I don't think that would be like a problem. I
hmm.
can show you the week. All right. So if you check the models, you can see the different sizes here.
Tiny or extra large. That's my experience when I go clothes shopping.
Yeah, so for the biomass, I think you just have tiny, large. So the good thing is you can, once you select the model, you can see the number of parameters
Mm,
that are being used here. So if you select the X large, you can see that it's using 300 million parameters.
mm.
Yeah, so the limitation that you might have could be related to loading those very big model on your
Yeah,
laptop.
yeah. So for the large ones, you probably want a GPU.
Yes, yes.
Brilliant. Okay, well, thanks so much for the overview. It's really lovely looking platform and great to see how you can, experiment with the models in it and visualize the results as well. Um, any closing thoughts before we finish up?
Yeah, so basically the platform is to kind of combine the end-to-end process from getting the data, having the models to run the inference and visualizing the result.
Mm,
But if you want to maybe create the data sets, like to prepare for model training, you you won't do it here. It's not enabled
mm.
yet, at least. But you can go on
Right.
the repository, you will find some interesting demo notebooks to
Mm,
prepare the data. And yeah, this is basically our chip creator module.
mhm,
So it's like you have original observations and you want to create a data set for training a model for that.
mhm.
There are a lot of parameters that you can select to train sorry, to extract the data, control the data source, the temporal tolerance, all of those parameters that you see here, you can control them when you are creating the data.
Yeah.
And you just have to go to the README page, you will see those notebooks there.
Okay, fantastic. I'll leave the links in the notes. Once again, thanks for joining me and all the best with the development work in your future.
Thanks, Orin. Thanks for having me.
See ya.
Bye.